Okay, hey folks, Mark Locklear here with a screencast on Chapter 4 and how to code loops. So we're going to, I think what I'll do here is we'll talk about precedents, and then we'll look at while and for loops. And I think for our coding exercise, I'll get you started on the guess number app and just sort of walk you through the logic there. So I think that'll work out good. Okay, so with that being said, let's look at desktop 1. Alrighty, so I'm going to provide this file inside Moodle 2 under the learning resources. If you just want to go in and play with it, you can. So let's talk about these operators. Basically allow you to just increment and decrement variables inside C++. So for instance, if I go in and let me comment out some stuff here before I get started. So the output looks a little better. All right, so we'll start off with this. All I'm doing here, I've got a simple variable that is an integer called count. I'm assigning the value of 1 to it, and then what this count plus plus is going to do is going to increment the values. It's just going to simply add 1 to it, and then we're going to see the output down at the bottom here. So for instance, move this up. So we can see here count is 2, right? And if I remove this, and ran it again, count would just be 1 because I hadn't added anything to it. Okay, count is 1. Okay, so let's in fact, if I do this, so here I'm doing count minus minus, so this is going to decrement the value. It's going to subtract 1 from it, and so we should get a value of 0. We can see that here, and then here we've got what's called a compound assignment, I guess we'd call this. Essentially, we're saying count, take the value of count, and then whatever the value is, we're going to add 1 to it. So count plus 1. So in this case, in this case, we should get 2 here, which is essentially going to do the same thing as this increment operator did earlier. Okay. Well, so I'm sorry, count is going to actually be the same. So count's going to continue to be 1 here. Because count is so I'm subtracting. So what's happening here is just walk through count. I start out with count being 1. I subtract 1 from that, so it's 0, and then I'm adding 1 back to it again, and that's how I end up with the 1 here. Okay, and then we can do this compound assignment. So this compound assignment, this line, what you see here is doing the same thing as this is. It's just sort of a shorthand way to, and maybe a more concise way to do it, right? So our count was 1 previously. Count should continue to be 1 because again, this plus equals is going to do the same thing. See, so here we've got count as 1. Generally, this is what you see. I mean, this is probably a more explicit way to do it, but I mean, this is pretty easy to read, and once you sort of wrap your mind around that, that's generally what you see that programmers using. This is pretty ubiquitous across programming. You see this just off the top of my head. Ruby, Java, and C++ have this same syntax. Pretty sure Python might too. So it's pretty ubiquitous across programming languages. Okay, let's talk about order of precedence. Let me uncomment this. So order of precedence is a mathematical concept such that whether you use parentheses or not, you may get a different order of operations. You might also hear the term order of operations. So let's just walk through it here. So here I've got an integer, a variable called price. I'm assigning the value of 100 to it. Here I'm saying price is equal to price times 1 minus 0.2. Okay, now if I run this now, let's look at the value of price. So if I look at this now, the price is 99. Now let's look at this statement right below it. I'm going to uncomment it out. Same exact statement, although I'm putting the parentheses around this 1 minus 0.2. Now let's run it and see what we get. So notice now I get price being 80. The reason that is the parentheses sets up the order of precedence or the order of operations here, such that whatever's in parentheses is always the math equation is done first. So in this case that I've got uncommented, 1 minus 0.2, that math is done first, and then the result of that operation, the result of the operation in parentheses, is then multiplied times price. So just be aware of that, whereas if you don't have any parentheses at all, you just are simply going to read left to right. So in this case up here, I'm doing price times 1, and then the result of price times 1, the result of that equation, I'm going to subtract 0.2 from it. So that's how you get the different results there. So just that's something to be aware of when you're doing sort of more sophisticated math equations, especially in one-liners. The order of precedence matters. Okay. All right. Let's look at a while loop. So while loops, go ahead and warm up. While loops and for loops, go ahead and warm up to those now, because we're going to be seeing plenty of those for the rest of the class. So while loops are simply a way to loop through code. If you have an indeterminate number, for instance, some of the exercises we'll do, we'll ask the user, would you like to try again? And they can sort of do a particular operation as many times as they want. Loops allow us to do that kind of thing. So here's a super simple example here. We're creating this, so you'll see this lots of times, this I, lots of times the, I guess the increment is where they came up with I, but you'll usually use the I variable for the incrementing of either a while or a for loop. So in this case, we're setting I equal to 1. We're going to create this variable called sum. We'll just assign 0 to it, but that's where we're going to tally up sort of, that's where we're going to tally up the increment that we do each time. So here inside our while loop, we've got while I is less than 5. So that means we're going to keep doing this thing. We're going to keep doing this stuff in the middle here. While I is less than 5, we're going to do all this. And then when I becomes greater than 5, we'll actually drop out of that loop, and then we'll do this cout statement here. So in this case, sum is equal to, I'm not even sure, sum is equal to 4, yeah, because yeah, we're adding 1 to it each time. And then notice we're outputting the count in here each time too. Notice we've got this cout statement. So again, I starts at 1. So the first time we come in here, I is going to be 1. And then we're going to add 1. We're going to add 1 to that I variable each time. So that's what this sum plus minus plus equals 1 does. And then I plus plus is going to increment I. So yeah, let me say that one more time to make sure I got that right. Again, we're going to output the value of I. We're going to add 1 to sum each time. So that's where we get the 1, 2, 3, 4. That's where we end up with the 4 here. And then we're going to increment this plus plus I. Notice this is a little different here. The book goes into more detail about it, so I'll let you read it there rather than me going in detail. But this is a sort of pre-assignment versus post-assignment, and you'll get a little different. You'll get a little different behavior depending on how you do it. Again, I won't go into it here for the sake of time, but you can read more about that in the book and let me know if you have questions on it. Last thing I wanted to do is I'm actually code out the for loop, only because I usually don't do too much coding live here because it's just a pain for you to watch me sort of fumble through. I do want you to see how the IDE can help you out. So in this case, I'm going to do a really simple for loop. So I'm just going to reset sum to 0 because that's the variable we're going to use to keep our sum. Now notice if I type 4 here, and yours may be a little different if you're using Visual Studio Code, but you should have something similar there. Now, and I can choose which one of these I want. I'm going to choose a simple for statement, and if I hit return, I'm going to hit return on my keyboard. Notice it gives me the structure of a for loop, and the structure of it is within the parentheses. I have the initialization value, I have the condition that I'm looking for, and then I have the increment value. So for instance, in this case, we'll do int I equals 1. So that's the initialization value. Now I'm going to tab here. I'm hitting tab on my keyboard. That's, and I notice that moved me over to the condition. So the condition is, how long are we going to keep doing this thing? So we're going to keep doing it as long as I is less than 5. All right. Again, I'm going to hit tab. That's going to take me over to the increment, and the increment in this case is going to be plus plus I. I'm sorry, plus plus, yeah, plus plus I. So I is what we're going to actually increment in this case. And then again, I can tab, and now I go down into the body, and these are the statements, or this is the stuff that I'm going to do as long as this for loop is running. So in this case, we'll do cout, and then we'll do I. So that's what we're going to print each time, and then we'll put just a space. And then for our sum, we need to sum is going to be plus equal 1. All right. And then at the bottom here, let's output this. So we'll do another cout statement. And again, this is going to be similar to our while loop. In fact, it may look exactly the same to it, or exactly the same as it. So I'll do \n sum, and then we're going to concatenate the sum to that, and then we'll do endl at the end here. All right, so if I run this now, let's go ahead and comment out our for loop. So let's see if I got this right. So I'm getting an error here, undeclared identifier sum. Okay, because I commented it out above, I need to initialize it with int. All right, let's try this now. Okay, so now I get the exact same functionality. It's actually good to sort of compare these two. Notice this for loop, the output is exactly what it was in this while loop here. But notice they're just a little different implementation. Generally, a for loop is used if you know the exact increment or the exact number of times you want to do something. Whereas the while loop, again, you may be getting input from the user, something like that. For instance, I'm thinking about the test score app. Maybe there's, I think it's the test score app will do where you'll prompt the user, okay, how many test scores are you going to enter? The user will enter that, let's say it's 5, and then that number 5 will be used to set the increment value for the while loop. But again, you could do that with a for loop too. So there's just depends on the implementation you want. All right, okay, we'll pause there, and then we'll go and let's look at let's look at our guest number app. Okay. So I'm asking you in the guest number app, I'm asking you to complete the book exercise. So this is exercise 4.3. See how far you can get without looking at the solution there. But in addition to what the book asks you to do, I'm also asking you to raise the random number from 10 to 100. And then I'm also asking you to, if the user gets within 10, so if they're either on the front side, less than or greater than 10, I want you to tell the user that they're getting warm. And I've got sort of a sample output of what that looks like. So generally, the first thing I'll do is once you have the sort of solution, the book solution, go ahead and run that. And then, so you know what? I'm going to just go stop this right now. So the first thing I like to do here is, let's see, can I stop this? Well, I guess I'll just go ahead and do it. So this is just 1 to 10. So this one's actually not that hard. So if it's too high, 6, 7, 8, 9, 10. Too high. 1, 2, 3. Okay, so 3 was my answer. So the first thing I like to do here with this is I'm going to add some debugging. We've got a debugging chapter where you'll learn stuff like this, but the first thing I like to do here is I'm going to add a cout statement that's actually going to tell me what the random number is. So I'm going to cheat. This is smart for a couple of reasons, but the biggest of which is just to save you time, and especially with the when you're trying to count to 100, it takes a few more tries to try to guess what it is. So rather than try and actually I need to put this in the wrong spot. So we're going to put this here. So this cout statement is going to actually tell me what the random number is, so I don't have to guess. And this is pretty common when you're writing code to put some debug messages in. It just saves you a heck of a lot of time rather than having to do what the end user does. So you can see here, I see random, your random number is 10. So I know right off I can just put 10 in here, and that's going to give me the right answer. So I would recommend just go ahead and do that right out of the gate. So you don't have to you don't have to actually play the game each time. You can test a specific result based on whatever that number is. Okay, so let's think about our logic. And again, I'm not going to do the whole thing for you, but hopefully I'll just get you started here. First, let's walk through the current logic we've got just so we're clear. So here, first thing we do is check out the error condition. So if the number is less than 1 or it's greater than your upper limit, in this case, our upper limit is 10. Upper limit's 10 up here. So if it's less than 1 or if it's greater than whatever the upper limit is, you go ahead and display an error message and you ask the user to do it again. And again, this is what I was talking about, the implementation of a for loop, where you don't know exactly how many times you're going to be doing this loop in advance. So a while loop many times is a good choice for this. We said we're going to change our limit. I asked you to change it to 100, so that's pretty easy, right? All we need to do is go in here and change our 10 to 100. So again, our first if statement is going to check for that we've got a valid entry from the user. And now we've simply got two other else if statements that are checking if the number is too high and the number is too low. So we need to add a bit more logic to it, right? In this case, we need to check that if the number is within 10 of what the random number is on the high side or on the low side, then we're going to tell them they're getting warm. So I can do a simple else if statement here. And so let's try that. I'm going to go here and do else. Again, if you try to get comfortable with using the IDE as much as you can. So if I just start to type else, notice it gives me an else if, and if I just hit return there, notice it gives me the condition. So the first thing I'm going to think about is what condition am I looking for here, that I'm looking for that warm, whether they're warm, whether they're within 10. Well, I can do something like if guess is, I'm going to say less than number minus 10. And then I'll put my curly braces in here. And now I can do, I'm just going to copy the code they've got here. And I'm just going to paste this in here. Let's see if I can tab that over. There we go. So too low, and I'm going to say, but getting warm. Now, I don't think this logic is quite right because I'm putting it before the other one. So I'm going to just change that, although I may be wrong. But now that we know what our guess number is, and it's going to tell us that, it's pretty easy for us to sort of test very specific conditions here, right? And in fact, another thing I want to do is let me go ahead and put a carriage return in up here, just to \n. I think that's what I want. Yeah. So let's test out this condition. What I'm looking for is if the number is less than what the random number is, but it's within 10, then I'm going to tell them it's getting warm. So let's sort of test that, what right now is a hypothesis. Okay, so I know what my random number is. That's nice. So I know I can specifically test this idea of it's less than the random number, in this case, which is 70, but it's within 10. So I'm going to say 65, and let's see what I get. Okay, good. So nope, 65, but you're getting warm. Now, one of the things you're going to need to learn, and this is just a general coding axiom, is you need to test all code paths or test all possible conditions. So while I'm at it, let me go ahead and check that if my number is less than the random number, but not within 10, it should just tell me that my number's too low. So for instance, if I do 50, okay, good, I'm liking that, right? So I've already taken care of that condition where the number is less than my random number, but if it's within 10, then it tells me I'm getting warm. And I also, while I'm at it, I also check that if I'm outside of that 10 number, I'm outside of that 10 range, that it just tells me I'm too low. And then of course I can guess the right number, 70, and it's going to drop me out. Okay. That is all I'm going to do. I'm going to stop right there. You should be able to sort of take that same basic logic if you like. Again, there's other ways to do this. You don't necessarily have to do it this way, but I think based on the way the book sort of sets things up for you, that's probably the best way to do it. Okay. That is all for now. Again, good luck. If you have any questions, just shoot me an email.